squares again, and today it's going to be a lot of the same things. It's basically like working backwards from those properties. It's going to be talking about conditions for these. It's like the test for them. We've got 3 of them sitting right here. These are going to be things that you're going to be looking for to decide what shape something is. So it starts off saying if the diagonals of a parallelogram are perpendicular, so guys, listen to me. It's got to start off as a parallelogram. That's the first thing you need to know. If you already know that something is a parallelogram, and then its diagonals are going to be perpendicular, then you automatically know that that is going to make it into a rhombus. Okay? So whenever you see this right angle in the center, right here, where the diagonals intersect each other at those right angles, then you know it is going to be a rhombus. Okay? Perpendicular diagonals means it has to be a rhombus. Another way that you can tell that a parallelogram, so we're starting as a parallelogram, and we're proving that it is going to be a rhombus again, is that they bisect a pair of opposite angles. If you see opposite angles bisected, right here like this, the opposite angles are here and here, they're cut in half, and here and here. If you see that, then you're also going to know that this parallelogram is a rhombus. There's only one more. There's not a lot in this, guys. Like I told you, this is building on something we already knew. There are just 3 of these. The next one talks about why it's a rectangle, and then we're going to kind of see how you can cheat and use one to do both, like 2 of one to get a different shape. So if you have a parallelogram again, and you're turning it into a rectangle, the way you can tell it is a rectangle is if the diagonals are congruent to each other. Now they don't have it marked on here because it gets weird. If I mark this piece congruent to this, it looks like I'm just talking about this little part right here. So they write it up here at the top and they say that RO, this entire thing, is congruent to MH, this entire thing. And if the diagonals are congruent, then you're going to be talking about a rectangle. So far we've got 2 tests for a rhombus, 1 test for a rectangle. We also have one for a square, guys, because a square is just a rhombus and a rectangle combined. So if you see these 2 things together, then you are going to be talking about a square. So if you have the diagonals being right angles or perpendicular to each other, and they are congruent to each other, then you know you're going to have a square. You need to know that, you need to write that, you need to do something so you see that. So if you have perpendicular and congruent diagonals, if they are perpendicular and congruent to each other, that makes it into a square. So one of the things you're going to have to do is identify and then tell me why. Tell me what it is, which one of these reasons that you can use. So you're going to look at these shapes on the next slide and tell me what those are and tell me why they are. Let's take a look at that. So we already know that these are all parallelograms. That's the first thing you need to know. So we're starting off with parallelograms. All we're trying to decide is a rhombus, a rectangle, or a square. So this first one, what shape is E1 going to be? Rhombus. Now I need a reason. What's the reason? There you go. Opposite angles are bisected. Opposite angles are bisected. Very good. Bless you. Opposite angles are bisected. Which way does it go? Across? Okay. E2. What shape? Okay, rhombus is correct, but we need a reason. Why is this making this into a rhombus? There we go. Perpendicular by, I can't even say it now. I'm saying what you said. Sorry, that's my fault. Perpendicular diagonals, which is a weird word when you say that all day. Perpendicular diagonals is the reason that that's going to be there. That's going to be a rhombus. On the next one, can we conclude that that is a rhombus, rectangle, or a square? We can't tell it's anything, guys. Let's say this length right here is 5. What does this length right here have to be? Let's say this one is 4. What does this one have to be? Okay. Are the diagonals the same length? No. So is it a rectangle? No. Are the diagonals hitting at right angles? No. So is there anything about this that tells us anything special about what type of parallelogram it is? So what do we say when we say that? Can I conclude that it's any of these shapes? Not enough information. And actually, based on the question, I would even say no is acceptable because they said, can you conclude it? And the answer is no, I cannot conclude it. They don't give me enough information. And you could even say no, and then the reason being not enough information. Okay, guys, on the next one, AD, this piece right here, is congruent to CB, this one right here. What shape is that? Rectangle. And it's a rectangle because why? Diagonals. She's on it. That's good. Are congruent. I love those days. Diagonals are congruent. Okay, guys. So now the other part of this, there's only one other part of it. There's not a lot. Like I said, we're doing a lot of the same stuff that we already did. So the next thing is going to be dealing with the algebra side of this and using those same rules to go and use, like, go backwards. So I do want to say something about these notes. For some reason, when I printed them, you can see there's space up here, but for some reason it didn't print the word. See how it's got rectangle, rectangle? These two were supposed to say rhombus, because you have to know what shape it is to know what rule to use, and this one is a rhombus. Put that on there real quick. Okay. So in a rhombus, these angles right here would be what? Equal to each other because the diagonal bisects opposite angles. Because of that, this amount would have to be equal to this amount. So 2x plus 39 would have to equal 6x minus 9. Okay, minus 2x minus 2x. That's going to make it 39 equals 4x minus 9. Add 9, add 9. 48 equals 4x. Divide by 4, and 12 equals x. Does it ask me to plug it back in? The value of x? What is it? No, just x, guys. They just want the value of x. So we're done when we get to here. This is the answer to the question. Notice I always go back and reread the question when I get an answer, see if I've answered it. Okay, the next one's a little bit different, guys. This is not setting equal. You don't. You gotta manipulate this picture a little bit. What do we know about the diagonals in a rhombus? They're perpendicular, which means they create what kind of angles? Right angles. That 90-degree angle. Once I have that, this triangle, like every other triangle on Earth, adds up to what? 180. So we do 3x plus 6 plus 8x plus 7 plus 90 equals 180. That's going to be 3x and 8x is 11x. 6, 7, and 90. Guys, add 6, 7, and 90. What was it? Equals 180. Minus 103. Minus 103. Ooh, good. The math is nice then. 11x equals, guys, 180 minus 103 would be 77, which means when you divide by 11, x is equal to 7. Nice. Okay. Anybody see anything on those two before I move down to the rectangles? Okay, guys, listen to me. This next one, you have to think about a rectangle. In a rectangle, the diagonals do what to each other? Bisect each other. But they're also the same length. Since they bisect each other and they're the same length, then all four of these pieces are going to be the exact same length. Listen to me. In a rectangle, they're the same length and they're bisected. So you get four equal parts. Because of that, and I'm going to trace in a different color for you to be able to see it, this triangle right here becomes a special kind of triangle. What kind of triangle has two sides the same? Oh, you got to know this for the exam, so let's review this. An isosceles triangle has two sides the same. Because of that, the base angles are also going to be the same. So these two angles have to be the same. So we would just set that 4x minus 12 equal to that 3x plus 4. Again, those are base angles in an isosceles triangle. You basically create four isosceles triangles in a rectangle. Minus 3x minus 3x. Guys, what's 4x minus 3x? X minus 12 equals 4. And then you add 12, and x equals 16. That's the answer to the question. Okay. Last thing about rectangles, and this actually is true in rectangles and in squares, and you see it a lot. Guys, you're going to see this on your test, I guarantee you, because people forget this one, so I know that they're going to test this. I'm telling you now, I would like star it, highlight it, do something. You need to know how to deal with this. Guys, anytime you have a rectangle, what do you know about the angles? They're what kind of angles in the corners? Every time. They're all right angles. Guys, this is a right angle. This is a right angle. This is a right angle, and so is this. So since these two angles are here on a right angle, they are going to add up to what? 90. 5x plus 2 plus 3x has got to equal 90. Solve that. 8x plus 2. Oh, guys, what I did, make sure we're clear on this. Combining like terms, these two need to go together. They're both on the same side of the equal sign. We're just combining them. 5x and 3x is 8x. You bring down the plus 2 equals 90. We want to isolate the variable, so we minus 2 minus 2. 8x is equal to 88. Divide by 8 and x equals 11. Very good. Okay, guys, that's your notes for today. So from here, we do need to go over your homework. So take a minute, put this away in your notes section in your folder.